Okay, so when dealing with multiplication problems, I think the most important thing to remember, or one of the most important, is that A, right, that's going to refer to the number of groups. B is referring to the size of the groups, and C is the product or the answer. And remember that A is operating on B. So for lesson number 12, we're taking a look at multiplication story problems and then identifying them with the correct or applicable story problem type. So the first one is repeated addition. So repeated addition story problems, excuse me, they represent this sort of for every or each or per idea. So think of questions like recipes or per day or for each, etc. So look at the example they give. Right, there's 3 packages of gum. Each package has 5 pieces inside. How many pieces of gum are there in all? So that would be an example of a repeated addition story problem. For rectangular area array and area problems, those are problems that have to deal with physical space or the physical arrangement of items. Okay, so for example, there's 5 rows of desks with 6 desks in each row. How many desks are there? Right, notice it's a problem that has to deal with physical space. A rectangle is 5 meters long by 6 meters wide. What is the area of the rectangle? Again, physical space, physical arrangement of items or things. Multiplicative comparison problems have a multiplicative relationship between 2 of the fractions in the problem, okay, or between 2 quantities. So when you hear language like times as many or times as much or 3/4 of, etc., that's a multiplicative comparison problem. So for example, Susie has 3 feet of yarn. Tom has 4 times as much yarn as Susie. How much yarn does Tom have? Okay, times as much is a big clue here. Susie has 3 feet of yarn. She used 1/4 of her yarn, so 1/4 of 3. How much yarn did Susie use? Okay. So we are going to skip Cartesian coordinate, Cartesian product problems. We won't use those this semester. So moving on to page 119. We're going to skip number 5 on page 119. But let's go through 1 through 4. A recipe for a batch of muffins calls for 1 1/4 cups of raisins. If Thomas wants to make 3 batches of muffins, how many cups of raisins does he need? Okay, so this might be a good time to pause it. So this is going to be a repeated addition. Why? For every batch of muffins, you're going to need 1 1/4 cups of raisins. I could probably write this as 3 times 1 1/4. Right? For every batch, you need 1 1/4 cups of raisins. And this idea of a recipe, right, typically used for every or per, depending on how much you want to make. Paul's wool scarf was 8/9 yard long. After he put it in the washing machine, it shrunk to 1/4 of its original size. So here you are making a multiplicative comparison. Right, you're saying 1/4 of 8/9. Kayla buys a piece of property that is 1/2 mile long and 1 2/3 mile wide. How many square miles of property did Kayla purchase? So we're already talking about area if we're talking about square miles, and we have length and width here. So obviously this is going to be an example of a rectangular array problems. We won't see these that much. And last but not least, Jin Young has 5/6 yards of ribbon. Shikaku has 2 1/5 times as much ribbon as Jin Young. How much ribbon does Shikaku have? So 2 1/5 times as much is telling us that there's a multiplicative comparison being made. And we're skipping number 5. So on page 120, we are being asked to write our own story problems. So for the first one, we're being asked to write a repeated addition problem. We're given a number sentence without units, and then we have to write the number sentence with units. So, write 2 3/5 times 2/3. So I can say something like, Professor E wants to make two and 3/5. Remember, this is the number, very important, number of groups. And B, this is the size of the groups. Extremely important. So I want to make 2 3/5 cups, or 2 3/5 groups, cups of lemonade, and now the size, or each cup of lemonade calls for 2/3 cups of lemon juice. How many cups of lemon juice will Professor E need? Right? It's repeated addition because I'm talking about right? I mentioned each cup of lemonade calls for 2/3 cups of lemon juice. So there's that idea of per, right? Like a recipe, or for each. 2 3/5 is the number of groups, and this is the size of the groups. So now they want us to draw a diagram. I'm going to do the by place meaning, which means I need 2 copies of 2/3 and 3/5 of 2/3. Okay, I need 2 copies of 2/3 and 3/5 of 2/3. So there's my BMU. Let's draw 2 copies of 2/3 You might want to pause it and see if you get the same answer. Right, so this is 2/3. This is 2/3. So I have 2 copies of 2/3, and now I need 3/5 of 2/3. Here's 2/3, and remember we need to split each third into fifths. It's 1, 2, 3, 4, and 5, and we're looking for 3/5. Remember that each of these rows represents 1/5 of 2/3. We want 3 rows, so that's 2, 4, 6. So we're looking at this right here. Okay, remember that this whole thing was the BMU, right? So this is 6 pieces of size what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now we need to add everything together, right? We got 2/3, which we can say is 10/15, plus another 2/3, which is also 10/15, plus 6/15. So we got 26/15, or we could say that is 1 and 11/15. So he'll need 1 and 11/15 cups. Of lemon juice. Okay, next one. And it's also the last one. So they want us to make a multiplicative comparison problem, and they really haven't given us anything except the diagram. So we got to take a look at the diagram. Here's the BMU, which means each of these stars represents 1/2, which means I have 1, 2, 3, 4, 5 halves. And my answer, it looks like it's just 4 stars, or 4 halves. Now, because the problem type is multiplicative comparison, right? We have to figure out what the multiplicative comparison is between these two. If I take a look at 5 halves, right, and I look at my answer, I can say that this is 4 out of 5 of this, or the solution is 4/5 of the quantity, right? Each of these is 1/2. So, in other words, 1/2 is equal to 1/5 of 5 halves. How do I know that? Well, I have 5 copies of a half. So 1/5 of that would just be 1/2, or one of these. My answer, though, is 4 of them. So the answer is 4/5. The answer is 4/5 of 5 halves. So I could say something like, Professor E had 5 cups of lemonade. He drank 4/5 of this amount. And then my question would be, how many cups of lemonade did Professor E drink? Okay, so I have this much lemonade. I drank this much lemonade, and my question is asking, how much is this? Okay, so this is 4 halves, or 2 cups of lemonade. Okay, remember, each of these is 1/5 of 5 halves. Okay, 1/5 of 5 halves is just 1/2. 2/5 of 5 halves is another half. This, another half, and this, the fourth one, another half. So altogether, he drank 2 cups of lemonade. Okay, what's the multiplication number sentence without units? Okay, 4/5 of 5 halves equals, or with units, 4/5 times 5 half cups. You could also say 4/5 times 2.5 cups. First one is better. That's it. If you have any oops, I forgot this. The multiplication with number sentence with units here is 2 3/5 times 2/3 cups. Okay, if you have any questions, just email me or let me know.